Copernicus data applications in geographic information systems, QGIS and ArcGIS, statistical Python, and machine learning classification. Use geographical information system for urban planning and disaster prevention and Python to build vegetable activity time series. Amazon Web Services machine learning for optimal classification of regions based on their photosynthesis levels. These are the applications that where we can use all the data from Copernicus. The data coming from Copernicus can be used as an input for this example of applications. The first, it could be used for geographic information system like QGIS and ArcGIS, for example, for urban planning and prevention of landslides and wildfires. Here we have a 3D picture of the vegetable activity on the mountains and the low photosynthesis levels on the low levels of the mountains, creating the risk of wildfires and landslides because you don't have vegetable that it is over the town that we have here. So this is the first application that we can do for the Copernicus data for urban planning and prevention of disasters. Then using Python we can use we can build a time series of the vegetable activity, and here we can have a statistical of the time series of two regions. The blue line represents the high FPAR indicator of Copernicus for the mountains, and the red line represents the low vegetable activity that it is on the lower part of the mountains. Lastly, but it is not less important, is that we can use all this input of data to make a classification of the regions using machine learning. In this case, for example, we can use the K-means algorithm, where we are going to classify the vegetable activity regions by levels, and we can do that using an advanced tools like the Amazon Web Services SageMaker with NVIDIA processor. For example, we have these geographical information systems of urban planning, the landslides and wildfires prevention in the southern part of El Quiché department in Guatemala. We have this, that the dry corridor of Guatemala, it is extended from the eastern part in the department of Zacapa and Chiquimula in the eastern part of the country, going to the frontier to Mexico in Huehuetenango, and in the middle, right here, we have a village called Santa Cruz El Quiché that suffered a large wildfires and large disasters during 2022. And we can measure this, the FPAR and the vegetable activity of the mountains to see that we have a problem here, because all this low vegetable activity is creating a great risk for wildfires and landslides when you have heavy rains over this small town or small village called Santa Cruz El Quiché, which suffer from all these kind of disasters during the year of 2022. So this is the first application that we can do with the data from Copernicus. We integrate this data with and the topography with QGIS, and then we can get a map to see what is the risk of this region in the urban planning. Then we have this small town also in Sayaxie in El Petén. El Petén, it is the region of the Mayan Biosphere Reserve, and we can see that the red square, it is the El Rosario National Park. We can see that the FPAR from Copernicus represents a extremely high vegetable activity all over the year for this area, which demands a good urban planning, because otherwise you will see that this town will destroy all these reserves. Like we can start looking this situation here, that we have a road that goes from from the town to another town neighboring to this, and here we can see that we have a risk of the destruction of this national park, which has an excellent vegetable activity. Also, we have a very large river surrounding this urban area. It is the river La Pasión, that if you don't take care of this natural resource, this urban city could destroy all these large water source. Another application for the Copernicus data input is that we can build a time series. Here we have the charts using a 3D map from QGIS using the FPAR indicator from March to October 2022. We have like the rainy season in Guatemala starts in May and it ends on October 22. And here we have the time series during this year. We can see that the vegetable activity on the mountains, it is very high because it goes in March, which is still the drought season. It is in 0.6 and it climbs to 0.8 or 0.85 during the rainy season. Okay, so that's why we see that the peaks of the mountains around Santa Cruz El Quiché, they are relatively in good shape and has a good health. But on the contrary, when we go lower of the mountains surrounding Santa Cruz El Quiché, we can see that the vegetable activity, it is not as high, and the maximum even during the rainy season, it is a 0.6. Okay, so for a range of 0 and 0.9, we could see that this range of 0.6, it has a low or a very low vegetable activity. Okay, so that's another application. And the last application that we are going to present here is that we can use an algorithm to classify the different levels of vegetable activity of a region, to have an idea of how it is the behavior of this area. Here we have the center of Guatemala, and we can see that the dry corridor of Guatemala, it is moving from eastern to west to the western part, and we have this situation that almost everything it is getting dried. So it is a large problem for immigration, because actually this region has one of the highest rates of immigration population to the United States. The only area just in the middle of this dry corridor, it is presented here, and we use an algorithm class called K-means to classify the different levels of vegetable activity, and then we can map these different levels of activity, and we see where are the higher risks and where are the resilient regions that resist the droughts and that we have to take care of them. We use the K-means using the Amazon Web Services. We use this Elbow method of K-means to see how many groups are the optimal number of groups for this region, and we see that there are 3 groups because we choose the number where the line starts to get flattened, and then we run the algorithm and we get this classification. The first group, we have the highest vegetable activity between 0.6 and 0.96. It is mapped here, and we can see that this is the region that has the most resilient area to droughts. Then the second group, it goes from 0.5 to 0.59. It is this region on the chart, and we can see that it is like the lower part of the mountains are the regions that are getting more endangered with a low vegetable activity, and the worst regions, it is on the lower part of all the mountains that it goes from 0 to 0.49. So we can check here that we have to take care of the lower parts of the highlands or the mountains, because otherwise we are have risks of floods, of landslides, and also that the wildfires will start on the lower part of the mountains, and it will climb very fast to the healthy regions like this. Okay, so these are all the applications that we can have with Copernicus. And if you have any question, you can write me to fernando@astast.info.